Games of chance. Two archers, Hugh and Mary, have a probability of 0.4 of hitting the bullseye, shown as the yellow region opposite, when they shoot at a target. They decide to play a game. In this game, they take turns to shoot at the target. The first person to hit the bullseye wins. They have a maximum of 3 shots each, and if neither has won by then, the game is declared a draw. Mary goes first. Part 1. Determine the probability that Mary wins the game. So, first of all, it's important to note that if Mary wins, she has a probability of 0.4, and probabilities must always add up to 1. So 1 minus 0.4 is 0.6, and this is the probability that she will lose. So Mary wins the game if she wins on her first, her second, or her third shot. But for Mary to win on her second shot, both herself and Hugh must have missed their first shots. Likewise, for Mary to win on her third shot, both of them must have missed with each of their first 2 shots. So in words, the probability that Mary wins is the probability that Mary wins on her first shot, or the probability that Mary wins on her second shot, or the probability that Mary wins on the third shot. So the probability that Mary wins on her first shot is 0.4. This is the probability that Mary wins, and we got that from the question. The probability that Mary wins on her second shot. This means Mary loses, and Hugh loses, and then Mary wins. So this is 0.6 times 0.6 times 0.4. So the first 0.6 represents Mary loses, the second 0.6 represents Hugh loses, and then the 0.4 represent Mary wins. Or, which means add, Mary wins on her third shot, means Mary loses on the first, and Hugh loses on the first, and Mary loses on the second, and Hugh loses on the second, and then finally Mary wins on the third. So this is going to be 0.6 times 0.6 times 0.6 times 0.6 times 0.4, and then adding them we get 0.59584. Part 2. Determine the probability that Hugh wins the game. Because there is a possibility of a draw, we cannot find the probability of Hugh winning by just subtracting the probability of Mary winning from 1. For Hugh to win, he must win on his first, second, or third shot. For Hugh to win on his first shot, Mary must have missed her first shot, because remember, Mary went first. For him to win on his second shot, there must have been 3 misses before. Again, for him to win on his third shot, the first 5 shots must have been missed. So, in words, the probability that Hugh wins is equal to the probability that Hugh wins on his first, or the probability that Hugh wins on his second, or the probability that Hugh wins on his third. So the probability that Hugh wins on his first, well, Mary would have to lose on her first throw, and Hugh would have to win on his first throw. So this would be Mary loses and Hugh wins, which is 0.6 times 0.4. For Hugh to win on his second throw, that would mean that Mary loses on the first throw, and Hugh loses on the first throw, and Mary loses on the second throw, and Hugh wins on the second throw. So this 0.6 to the power 3 represents Mary loses, and Hugh loses, and Mary loses. And the 0.4 represents Hugh winning on his second throw, which is really the 4th throw of the game. Or, which means add, Hugh wins on his third. So this is 0.6 to the power 5 times 0.4. 0.6 to the power 5 represents Mary loses, and Hugh loses, and Mary loses, and Hugh loses, and Mary loses. And then the 0.4 represent Hugh wins. So multiplying out the brackets and then adding, we end up with 0.353704. This is different probability to Mary because Mary went first. Part 3. Explain why this is not a fair game. Who does the game favour? Because the probability that Mary wins is greater than the probability that Hugh wins, the game is not fair, as it favours Mary over Hugh. Part 4. Suggest a way to make the game fair. The advantage lies with the person who goes first. So if the game started with a toss of a coin to see who goes first, then it would be fair. In this case, each would have a probability of a half multiplied by 0.59584 plus 0.357504, which is equal to 0.476672 of winning. So remember, this is the probability that the person who went first wins, and this is the probability that the person who went second wins. At a games arcade, you have to pay €2 to play a game of chance. In this game, 2 dice are thrown. If the total of the numbers on the 2 dice is 2, 3, 4, 10, 11 or 12, you double your money, i.e. you get €4 back. 2 doubled is 4. If the total is 5 or 9, your stake, €2, is returned to you. However, if the total is 6, 7 or 8, you lose your stake. Part 1. What should the random variable x be for analysing this game? What are the possible values of x? The random variable x should be your financial state after playing the game. The possible values of x are +2, 0 and -2. So you could be up €2, you could break even, or you could be down €2. Part 2. Determine if this game is favourable or unfavourable to a player. When 2 dice are thrown, the number of possible outcomes is 6 by 6, which is 36. The possible totals are shown in the table below. So if you land on 1 and 1, 1 plus 1 is 2. There's only one way that you can do that. If you land on 1 and 2, or 2 and 1, the total is 3, and there's 2 ways of doing that. If you land on 1 and 3, or 2 and 2, or 3 and 1, the total is 4, and there's 3 ways of doing that, and so on. So there's 4 ways to get a total of 5, there's 5 ways to get a total of 6, there's 6 ways to get a total of 7, there's 5 ways to get a total of 8, there's 4 ways to get a total of 9, there's 3 ways to get a total of 10, 2 ways to get a total of 11, and 1 way to get a total of 12. So remember, if you get a total of 2, 3, 4, 10, 11 or 12, you double your money. So total of 2, 3, 4, 10, 11 or 12, you double your money. A total of 5 or 9, you get your €2 back. So a total of 5 or a total of 9, you get your €2 back. Or a total of 6, 7 or 8, you lose your money. Total of 6, 7 or 8, you lose your money. We can now form a probability table for x and extend it to calculate the expected value. So remember, if you get a total of 2, 3, 4, 10, 11 or 12, you double your money, get €4 back. So if you get any of these totals, you double your money. So we need to work out the probability of this happening. So the probability that you get a total of 2 is 1 over 36, because there's only one way you can do that. The probability of getting a total of 3 is 2 over 36. There's 2 ways of doing that. The probability of getting a total of 4 is 3 over 36. Probability of getting a total of 10 is 3 over 36. Probability of getting a total of 11 is 2 over 36. And probability of getting a total of 12 is 1 over 36. So this simplifies to 12 over 36, or a third. And our variable x is +2. You'd be €2 up. And 2 times a third is 2/3. The probability of getting a total of 5 is 4 over 36, and the probability of getting a total of 9 is also 4 over 6. This simplifies to 8 over 36, or 2/9. And remember, if you get a total of 5 or 9, the €2 is returned to you. So basically you get €0. So 0 times 2 over 9 is 0. And then the probability of getting a total of 6 is 5 over 36. The probability of getting a total of 7 is 6 over 36. And the probability of a total of 8 is 5 over 36. If you get a total of 6, 7 or 8, you lose your stake. So you end up with minus €2. Simplifying this, we get 16 over 36, which is 4 over 9. And minus 2 times 4 over 9 is minus 8 over 9. So adding these, we end up with minus 2/9. So the expected value is the sum of the x values times the probability of x, which ends up being minus 2 over 9 euro, which is minus 22 cents. Since this is negative, the game is unfavourable to the player. Part 3. Calculate the entry fee that would make this a fair game, assuming that you win €2 for a total of 2, 3, 4, 10, 11 or 12. Your entry fee stake is returned for a total of 5 or 9, and that you lose for the other totals. So let the entry fee be €y. Then the elements of x are going to be up €2, 0 or minus y. So we set up our table again. We have €2, up €2, just like before, and the same probability. 2 times a third is 2/3. We again have 0, and the same probability. 0 times 2 over 9 is 0. But now we have minus y. Again with the same probability, and minus y times 4 over 9 is minus 4y over 9. Adding these, we get 2/3 minus 4y over 9. So we basically just swapped the minus 2 for minus y, and the rest of the table is the same. So for a fair game, we want the expected value to be 0. So we take our total for x times probability of x, and we let it equal to 0, and then we just solve for y. So we bring the minus 4y over 9 over the equal sign, it becomes plus 4y over 9. And then multiplying across by 9, we get 4y is equal to 6, and dividing by 4, we get y is equal to 1.5. Thus, a fair entry fee for the game would be €1.50.